All right, so last class period we added and subtracted rational expressions, but those rational expressions, what do you remember about the denominators? They were the same. They were like denominators. So, for example, in let's just kind of review this one. So you have 3x minus 2 divided by x plus 7 times x minus 3, and you're subtracting 2x minus 9 and divided by x plus 7 times x minus 3. So we talked about that last class period, something like that. So remember, when adding or subtracting rational expressions, before you can combine them as one, the denominators have to be alike. In this case, they are. So since they're like denominators, I can write those two rational expressions as one. So in other words, my denominator will be x plus 7 times x minus 3. Now let's talk about the numerator. If you're adding, it's not that difficult to deal with. It's subtracting that you have to be careful with. So my first numerator is 3x minus 2. Then I'm subtracting, you got to be careful with that part. You're subtracting that second numerator. But the second numerator has more than one term. So remember, you're subtracting, in this case, two things. You're subtracting a 2x, and you're subtracting what else? A negative 9. So what we talked about last class period in that particular case was, remember, we used parentheses. So inside the parentheses is what I would be subtracting. So what goes inside that parentheses? 2x minus 9. Then what we did next was we got rid of the parentheses now. So I'm going to distribute that negative symbol. So I get 3x minus 2, and then what does the rest become?
Negative 2x, positive 9.
Negative 2x plus 9, all divided by the denominator, which is x plus 7 times x minus 3. Okay, now what was the next step we did?
Combine like terms.
Okay, when I combine like terms, I get 3x minus 2x is x, and then the negative 2 plus 9 is 7 plus 7, divided by x plus 7 times x minus 2. At that point, you got to remember some stuff you did in that first section of this chapter. What was the next step? Reduce.
X negative 3.
X is negative 3? Okay, yeah, you're right. Thank you. All right, so you reduce. So you divide out the x plus 7. Now remember, you just don't cross those out because you know that we divide them, what factors are there? Ones. They're factors of ones. And so therefore, what's the answer?
1 over 3, x negative 3.
1 divided by x minus 3. Okay? Now, what we're going to do next class period is this idea. So next class period, we're going to add, subtract this kind now. So suppose I had 2x minus 1 divided by x plus 6, subtract 7x divided by x minus 2. So what do you notice about those two rational expressions that I'm subtracting? The denominators are not alike. They're different. And so you remember when you subtracted, let's say, this, 2/3 subtract 4 fifths, let's say, what did you have to do? Find the least common denominator. Now, you could use a common denominator, but we always chose to try and use the least. And what would be the least common denominator here? 15. And so what you did next was you wrote two fractions with that denominator. And then you wrote equivalent fractions. So remember what you did at that point was you said 3 times what is 15? But what you do to the denominator, you had to do to the numerator, so that became a 10. And over here, 5 times what? 3 will give me 15. But what I do to the denominator, I do to the numerator, so that becomes a what? And so then you then wrote this as one fraction. What's 10 fifteenths minus 12 fifteenths? What's 10 fifteenths minus 12 fifteenths? Not 2 divided by 15, negative 2 divided by 15. And that's what you did in a previous course. That's the idea you're going to use here. So basically, you have to find the least common denominator. So before you can do all that, though, all this right here where we wrote equivalent fractions, you need to know how to find the least common denominator when variables are involved. See, when it's just numbers, you have enough experience from previous years to be able to do that without difficulty, if it's just numbers, to find the least common denominator. But when variables are involved, you don't have that experience. So that's what we're going to do now. We're going to talk about how to find the least common denominator when the denominator contains variables. Okay? All right. So let's talk about that. So this was review to what we're about to do. So now remember, this part we're going to do next class period, where we actually do the work here. But before we do that, you need to know how to find the least common denominator. So finding the LCD. Remember, LCD means least common denominator. Okay, least common denominator. All right, so we're going to start with some easy ones. Easy ones meaning no variables. So number 1, suppose I had 1/2 comma 1/5. Suppose those two are my fractions. What would be the least common denominator of those two denominators? Huh? 10. 10 will be the least. All right, so your LCD would be 10, right? So 10 would be the smallest common multiple. Now notice I use the word common. So what that means is this. So if I look at the multiples of 2, meaning this, what numbers will 2 go into evenly?
1 and 2.
Well, not 1. 2, because 2 times 1 is 2, right? 4, because 2 times 2 is 4. What's the next multiple of 2? 6. 3 times 2. I'm sorry. Then 4 times 2, and so on, right? 10, 12, 14, 16, 18, 20, 22, and so on. Y'all agree? Okay. The multiples of 5, what's 5 times 1? What's the next one? 10, 15, 20, 25, and so on. Y'all agree? Yeah. So there's an infinite number of those. But if you look at the multiples they have in common, you have 10. What else do you have? 20. And there's many more, right? You just don't see them. 30, 40, 50. But of the ones I have circled, what is the least? What's the smallest? 10. So that's what we mean. The least common denominator would be 10. All right, let's look at number 2. Suppose this time I had 2 8s, comma, 5 6. 2 8s, comma, 5 6. Now again, you had enough experience to be able to tell me what the least common denominator is. Not a common denominator. I don't want just any common denominator. I want the least. 8's not the least, because 6 is not going to 8 evenly. 24. 24. 24 is the least common denominator. 8 goes into 24 and 6 goes into 24 evenly. And that's the smallest one. There's 48, but 48 is not the least. 48 is a common denominator. All right, number 3. Suppose I had 5/12, comma, 4/18. What's the least? 36. 36 is the smallest number that 12 and 18 go into. Sometimes when the numbers get big, what you can do is this. Always start with the largest one and look at its multiples. 18. 18 times 1 is what? Does 12 go to 18 evenly? No. 18 times 2 is what? Does 12 go to 36 evenly? Yes. So 36 is your answer. We could do the same thing with number 2. What's the largest one that you see here? 8. 8 times 2 is 12. 18. 8 times 2 is 16. Does 6 go to 16 evenly? No. 8 times 3 is 24. Does 6 go to 24 evenly? Yeah. So 24 is what we used. All right, now, see, the numbers are not that bad. What if I had this for number 4? 3 divided by x squared. Now we're going to do variables. 5 divided by x to the 5th. What do you think the least common denominator is?
X to the 6th power?
X to the 6th? Okay. What else?
Oh, wait. X to the 10th power.
X to the 10th?
Yeah.
Okay. Anybody else? Huh? X to the 10th? Okay. All right, so let's talk about this. Let's see if x to the 10th. So y'all are saying, y'all think, some of you, not all of you, because only a few people said anything. So you're saying you think, now put a question mark here, that the answer is x to the 10th. Okay? All right, let's go back to numbers 2 and 3 for a moment, okay? So let's look at number 2. Let's go back to number 2. So we have 2 8 and 5 6. And what I'm going to do is I'm going to rewrite 8 and 6 using a product of prime numbers. Y'all did that in the previous course. In other words, 8 I can write as a product of two numbers. One prime for right now, like 2 times what?
4.
4. 2 is a prime number. 4 is not prime. 4 is composite, but I can rewrite that as 2 prime numbers. What is it?
2 and 2.
2 and 2. So 8 is 2 times 2 times 2. So you agree 8 is 2 to the 3rd? Okay. So 8 is 2 to the 3rd. Let's talk about 6. 6 you can do in your head. 6 is the product of what 2 prime numbers? 2 and 3. All right. So I wrote 8 and 6 as a product of prime numbers. Now we know that the LCD of 8 and 6 is what? 24. Okay? I'm going to ask you this. Do y'all agree that 24 is 2 to the 3rd times 3? What's 2 to the 3rd?
8.
8. And what's 8 times 3? 24. Okay? I'm going to come back to this in a little while. Let's go to number 3 now. Where we had 5/12 and 4/18. So let's talk about 12 and 18 this time. 12, y'all agree, is 2 times 6? And then 6 is 2 times 3? So I can write 12 as 2 to the 2nd power times what? 3. Right? 18 is 2 times what? 9. And 9 is 3 times 3. So I'll agree that 18 I can write as 2 times 3 squared. Okay? And we found the LCD to be what?
36.
36. I'm going to go ahead and do that here. So 36. Do y'all agree that 36 is 2 squared times 3 squared?
Yes.
What's 2 squared?
4.
What's 3 squared?
9.
What's 4 times 9?
36.
36. All right, let's talk about what we just did here. So 36 is 2 squared times 3 squared, and then here 24 is 2 cubed times 3. All right, listen carefully what I'm about to say. When I looked at 8 and 6, look at your factors of 8. So a factor of 8 is 2, and it occurred how many times? 3. Okay? 6, I have a factor of 2. It occurred how many times as a factor? 1, because the exponent's 1. 3 is a factor and occurred how many times? 1. So your LCD has to include every factor that you see. I saw factors of 2 and I saw factors of what? 3. So my LCD has to have a factor of a 2 and a factor of 3. Question now becomes, how many do I need of each? Well, I know that in my answer, how many did I use? 3. Okay, let's talk about where this 3 comes from. How many factors of 2 were here? 3. How many factors of 2 were here? Which one did I use? The one with the largest exponent. So you don't count how many you have altogether. So you don't say there are 4. You say there were 3 here. How many here? 1. So I need how many? 3. Let's talk about 3. How many factors of 3 are in here? 0. How many factors of 3 in here? How many did I use? 1. Let's go to 36. I have a factor of 2 and I have a factor of 3. I'll see those. So you see a 2 and a 3 in here? Okay, question is, how many do I need? How many factors of 2 are here? How many factors of 2 here? How many did I use? 2. How many factors of 3 are here? How many here? How many did I use? 2. Okay. Now, I'm going to ask you this now. Do y'all still agree with x to the 10th as being the LCD? No. What is it?
X to the 7.
God, come on, dude. We just talked about this. X to the what power?
7.
So x to the what power? X to what power? 5th. X to the 5th. I didn't hear you. I heard him. I kept hearing him. X to the 7th. And that's why I said, oh, come on, dude. We just talked about that. How many factors of x are in here? How many factors of x are in here? How many do you use? 5. We had that whole discussion. And there's a whole point of having this whole discussion so you can get this quickly. All right, let's look at number 5. Six divided by x cubed y to the 4th, comma, 7 divided by x to the 5th, y squared. So 6 divided by x cubed y to the 4th, and then 7 divided by x to the 5th, y squared. So let's talk about the LCD. So my factors involve the variables x and what else? Y. So I know I'm going to need some x, I'm going to need some y's. Okay. How many factors of x are in here? How many in here? How many do I need? 5. Let's talk about the y's. How many factors of y are in here? How many in this denominator? How many do I need? 4. That's your least. Okay, that's your least. All right, number 6. Number 6, suppose you had 2 divided by 5x to the 7th, comma, 3 divided by 20x to the 9th. All right, now this time I have some coefficients other than 1. Let's talk about the coefficients first. 5 and 20. What's the smallest number that 5 and 20 go into? Oh, 20. 20. 20 does not go into 5. 5 goes into 20. Evenly. What about your variables? X to the 9th. So there's your LCD. So 20, x to the 9th. So you have to know how to find the least common denominator because next class period we're going to be adding and subtracting these, in which case you would have to find equivalent fractions. All right, next one. 4a divided by a plus 2, comma, 2a divided by a minus 3. So let's see if you remember how to determine what your factors are. In that first denominator, what is or are my factors? A plus 2 is your factor. A plus 2. Not A, because remember, factors, if A was your factor, then that better be a product right here. So together, that is your one factor. What's the only factor that you see in that second denominator? A minus 3. All right, so you know your factors. What are your factors in the first denominator? A plus 2. What's the factor in your second denominator? A minus 3. So remember, your LCD has to include those factors we just talked about. So your LCD, your one of your factors better be what? A plus 2. And the other factor better be what? A minus 3. And then now the question becomes, how many of each do I need? All right, so that's our discussion now. How many factors of a plus 2 are in this denominator? 1. How many factors of a plus 2 is in this denominator? 0. So how many do I need? 1. So a plus 2 to the first power. How many factors of a minus 3 are in this denominator I'm pointing to? 0. How many are here? 1. How many do I need? So there's your LCD. Compare that one with number 8. So let's suppose in number 8, I had this. 4a divided by a plus 2 times a minus 3 cubed, comma, 2a divided by a minus 3. So it's almost the same idea or the same expressions except I added in some extra factors. What I would do first in this one is just mention or just figure out what factors do I need to begin with. In my LCD, I need at least how many factors? An a plus 2 and a what? A minus 3. So I need those in there. Now the question becomes, how many of each do I need? So let's talk about that. How many factors of a plus 2 in that first denominator?
1.
How many in that second?
0.
So I need how many? 1. So I'm good with that a plus 2 that I have here. Let's talk about the a minus 3. How many factors of a minus 3 in the first one?
3.
How many in the second one? How many do I need? 3. Don't say 4. We talked about that. You don't add those as the largest exponent that you see. That was that whole discussion again. It's kind of like 1 minute y'all get it, and the next minute y'all forget it. Number 9. 4x to the 5th divided by x minus 2 squared, comma, 2x divided by 5x minus 10. All right, now this is where you have to start remembering some things now. So we're adding some stuff here. What might you want to do first?
Your factors.
Factor that second denominator. So how can I factor that second denominator? 5 times x minus 2. Okay? So now I kind of know what my LCD is. So what's the LCD, do you think? What do you think? Okay, I agree that part of it is x minus 2 squared. Is it the only part? 5 times x minus 2. Squared, yes. All right, so remember, you got to take care of that coefficients also. So notice what we said. Every factor we see, we got to use. So I see an x minus 2 here, right? So I'm going to put it here. I see a 5, so I need to use it. I see an x minus 2. I already have it listed. Question is, how many do I need of each? How many x minus 2's do you see here? How many do you see here? 1. So I need how many? 2. Okay. 10. Suppose I had 3x divided by 2x minus 8, comma. 6. Let's do a 7x. 7x divided by 3x minus 6. All right. So before you find the LCD, you got to do what now? Factor. You got to factor. How do you factor that first denominator?
GCF is 2.
GCF is 2, so it'll be 2 times what?
X minus 4.
Over here, GCF is 3, so it'll be 3 times
X minus 2.
x minus 2. So what do you think the LCD is? What's the smallest number that 2 and 3 go into? 6. So it'll be 6, right? 6 times what?
X minus 4 times X minus 2.
Yep. X minus 2. So if you look at the coefficients first, 2 and 3, smallest number that 2 and 3 go into is 6. Then I need an x minus 4, and the question is how many do I need? Well, there's 1 here, none here, so I need 1. The x minus 2, there's 1 here, 0 here, I need 1. So there's your LCD. Okay? All right, let's look at number 11. You have x plus 6 divided by x squared plus 2x minus 8, comma, x minus 7 divided by x squared plus x minus 12. What do you do first? Factor. So you factor this as x, what else? 4 and 2. And I think it'll be a plus 4 and a minus 2. Okay? And again, check before you go 1 if you need to. The outer's a negative 2x, the inner's a positive 4x. When I add them up, I get 2x. And then 4 times a negative 2 is a negative 8. Over here, when you factor that, it'll be x plus 4, x minus 3. You agree?
Yeah.
So what do you think the LCD is? X plus 4. How many x plus 4s will I need? Just 1. Good. You don't count altogether. You just count how many factors in each one. I also need a what? X minus 2. And I also need a what? X minus 3. So I just need 1 of each. That's your least. Okay? All right, question at this point. All right, so that takes care of that part. In order for you to be able to go into that next part next week, you have to know how to find the least common denominator. Okay.